Okay, all right, cool. We're going to do a quick little experiment to try and attract more people back into the room from the garden. So on the count of 3, we need to shout as loud as you possibly can, and then the next person who comes in the door, shout even louder, okay? You ready? 3, 2, 1. Hey, Tila. Cool, that worked. The penultimate talk is about to come up, so keep the energy up, do some jumping jacks after the next talk, and we're nearly there. Your nostalgia has turned the world black and white, and as you walk along the beach, a building appears lit with a neon sign, Rick's Cafe Americain. You wander in and join the party of all the gin joints in all the world. You walked into this one. You walk to the bar and call for a drink. If it's July 2015 in Hamburg, the bartender asks, "What time is it at home?" "I don't know," you think. "I didn't charge my watch." On the bar, you notice something sparkling. It's the jewel that Daenerys Targaryen stole from you earlier. But you don't take it. Maybe you don't need it anymore. A mysterious man reaches for it and places it on the roulette table. You pick up your drink, and as you sip, you realize this is not a bar at all, but a church. And the mysterious man in the corner is Michał Taszycki.
Oh, yeah. We developers are privileged to live in a remarkable time. Our computers are fast and are relatively inexpensive. So they are definitely cheaper than our wages. So thanks to that, we are more productive than ever before. We can allow ourselves to use inefficient but lovely languages like Ruby. We can use even weird languages that are usable only if you use the good parts. So when we need to improve our programs to make them work faster, usually the first solution is to buy a new computer, buy a new hard drive, buy another computer. And usually this is a good solution and it works at least in the beginning. So this is great because our computers are so fast that we can do pretty much anything we want. We can create abstractions, we can use frameworks to build blogs in 10 minutes. We can use game engines to create games in 2 days, and that's great. That's fantastic. However, I believe that we've lost something along the way. So as Brian said yesterday, what we have in our pockets are pretty good computers. So mine has 5 years, and it has a 1 gigahertz processor, plenty of memory, and it's like a, well, much, much better than thing that we used to go to the moon with. And the thing is with my particular phone, the problem is that whenever I upgrade it, it becomes slower. So We became a bit lazy because we don't need to optimize our programs to work on existing machines. We can rely on the fact that another computer, another model will be faster, will be better, so we don't care about old stuff. When was the last time when you built something from scratch? I mean, like a really low level. I've seen yesterday a couple of people were learning, thanks to David, Arduino. And that was great. I've seen that they were really happy. But what I want to propose is something even lower level. How long ago have you built something in assembly? So building things in assembly is hard because right now the modern processors are really complicated and it's really hard to understand what is going on. So it would be great if we had like a smaller computer that we could understand and do some cool stuff with that. Well, we have a Raspberry Pi. That's not really the thing because it's a normal computer with a normal processor with Linux on top. It would be great if somebody invented a machine that was fun to program, that was simple. Wait, it already exists. I want to convince you that programming Commodore 64 is the best thing to learn something like that. So, how many of you know what Commodore 64 is? Cool. For those who don't know, it's this beauty. And it is actually the highest-selling single computer model of all time. It has 1 megahertz CPU, so it's actually like 18 times slower than Arduino, but it's still good enough. It has 64 kilobytes of memory. So it's actually 16 times more than everybody would ever need, right? It has 8-bit registers. But there is a sad thing about Commodore 64. It is not produced for more than 20 years. There were 70 games and 47 demos released in total last year. Actually, in a couple of years, well, since 2010, the similar number of games and demos are released every year, and it kind of seems to be growing. But I'm counting only the full games and like really complex demos that are released. When you count everything that gets released for Commodore 64, you count them in thousands. So it's like a really small games, stupid demos, and every graphics, every sound. It's like 1,800 released last year. And it's kind of growing. There are many successful crowdfunding campaigns lately. So currently running is the translation of the Generation 64. It's a book about people who, well, grew up with Commodore 64 in Sweden and now became CEOs of companies and great programmers. There is the story of Commodore 64 in pixels. This one is already released. It's like a catalog of games with beautiful printed screenshots talking about the things that were released on good old days. This one is interesting. So there is a guy in Chicago who owns the original molds for cases of Commodore 64, and he created a Kickstarter to create new ones for people who wanted to buy them, and it was like hugely successful. People who created music in those times are creating like new versions of the music, and actually a couple of weeks ago in Brighton there was a live concert with only the people who created music 20 years ago. So it was only like the music for Commodore 64. People love Commodore 64. I love Commodore 64. So I'm the founder of 64bytes.com, and I'm actually creating screencasts that are related, well, that are about programming Commodore 64. So if you program in Ruby, you might know about Ruby tapas. So it's basically the same thing, but for Commodore 64. So programming Commodore 64 is among the best computer-related hobbies that I've ever had. So I started with BASIC. It was my first computer ever, and this was my first experience with programming. But 2 years ago, I decided, well, it's time to learn assembly. And it appeared it was not that hard, and it blew my mind. It was like a really great experience. I want to show it to you. So the first thing, great thing about Commodore 64 is you can program it on your computer. So this is an emulator that works on Mac. There is a version on Linux and Windows, and it works. So my first program looked basically like that. It was 10 prints. It was probably Commodore 64, but we can go crazy and write something else. So code it. Then there was 20, go to 10. And after I ran those programs, I was like, oh God, something's wrong. Oh, got 0. Okay, thank you. Nice. So when I first ran that, I was like, Mom, come see this. This is great. And she was like, oh, yeah, it is. Good for you. So yeah, that was my first experience with programming. And yeah, I think thanks to that, I became a programmer. But 2 years ago, I did something else. Oh, so you can't see that. OK. OK, I changed the full screen, so maybe that's... OK, great. So let's do it like in a different way. OK, that's better. So basically, this is the program that animates characters and colors. So let me show you what it does. Basically, there is an animation at the top row that animates characters, and there is animation that animates colors in the second row. There is the loop here that cycles characters, cycles colors. There is the delay, because it would be too fast. And then we jump back to the loop. So if instead of jumping to the loop, I return from subroutine, I will exit from the program. So this way, I can show you each iteration. So it works like that. That's cool, but that's not something that blew my mind. So this is the easiest way to animate things on the Commodore 64, but you can do it in a different way. So if I delete the cycle colors from here, I can make Commodore to drive my animation automatically. And yeah, you'll see how it goes. So first, I need to disable the interrupts. Then I need to load into one of the registers half of the address of the cycle colors subroutine. Then I load it to another address, well, to the another register, the other half of the address of cycle colors. I have to do it byte by byte because we have 8-bit registers and the addresses are 16 bytes, 16 bits. Then we store the first half of the address in the interrupt vector place in the memory. Then we store the second part in the interrupt vector +1. And then we enable the interrupt again. So in this way, I injected the subroutine that cycles colors into the interrupt handler. So I still need to change the cycle colors method to, instead of returning from subroutine, to jump to the place called interrupt address. So this way, instead of calling the usual interrupt handler, the computer will call my subroutine, and then my subroutine will call the handler. So if I didn't make the mistake, it works basically in the same way, but the real magic happens when I return from the program. Now, if you look at the top row, you can see that there is only one iteration run of the program, and each time I run the program, there is one iteration running. But the second one happens automatically, and I can even write over it. And this is amazing. So this is like a 30-year-old computer, and it feels like asynchronous programming. So that really blew my mind, and I'm addicted to programming Commodore 64 since then. OK, let's get back to the presentation. Commodore 64 has plenty of graphical modes. And when I say plenty, I mean that. So the usual thing that you see on the screen is the normal character mode. The resolution is 320 by 200 pixels. And there are 40 characters and 25 rows of them. Each one has one foreground color, and there is one background color. And you have 256 characters to choose from. And well, you can write stuff on screen, but you can also create graphics like that. So at the top, you can see that the common color is the light green, and there are different foreground colors. So those are just redefined characters. And at the bottom, you have two different colors. But wait, aren't we supposed to have only two colors per image? Well, there is a trick involved here. So Commodore displayed graphics on the television set. So basically, the graphical processor was synchronized with the electron beam that was creating the image. And actually, you could get an interrupt that would tell you where the electron beam is. So in here, at this line, the program runs that tells you, well, I'm here. So we can actually change the background color to a different thing. And either at the bottom or at the top, you have another subroutine that changes the color back. So that this way, you can have more colors on the screen. There is also multicolor character mode that gives you 3 additional colors per character, but the resolution is worse. So horizontally, you have only 160 pixels, so they are wider. But you can have graphics like that. So as you can see here, those things are made using characters. This is not. And this is character. So you can see that the pixels are wider, but you can have more colors with that. There is also extended background character mode, which is built in to the Commodore 64. It gives you some additional colors, but it gives you the better resolution, but only 64 characters to choose from. And you can have graphics like that. So this is actually a game which first was created in Flash and only looked like Commodore 64, but one guy who is specializing with demakes created a game for Commodore 64. So there is also a bitmap mode, which is not truly bitmap mode because in Commodore 64 you write everything using characters. So this time you have 1,000 characters, but you can define them to whatever you want. So it actually behaves like a bitmap, but feels differently. And you can write images like that. You can draw images like that with this mode. So the weird thing about that is that you don't address pixels like row by row. You address pixels first row of first character, second row of first character, and so on, and then you go to the next character. So addressing the bitmap is weird and different, and you need to be familiar with the weirdness of Commodore 64. And if you get over that fact, you can create cool things. So this is another image drawn in this mode. Yeah. There is also multicolor bitmap mode that is basically has the same thing as the multicolor character mode. Pixels are wider, you get more colors, and you can make better pictures, like this one. And there are plenty of more different modes, and every year people find out how to get more colors, how to get more pixels on screen, and they invent different new graphical modes. So, for example, when you display the image on PAL or NTSC, you have something called, well, you experience the color bleeding. And developers use that to their advantage by mixing colors and creating more than 16 colors on the screen, which is pretty crazy. And they can also use the fact that you have, when you display things on the TV, it blinks. And you can actually hide the fact that you display two different images. They are blinking, but it seems like they have better resolution. So you can achieve images like this one. So you can see that it seems like there are more than 16 colors on this image. Or this one. The thing about characters and the fact that you have only 1 megahertz processor is that you cannot write 320 and 200 by 200 pixels on the screen in one frame. It's just too much processing power. So designers of Commodore 64 developed something called Sprites, which are just movable objects that you define the bitmaps. They are small, 24 by 21 pixels, but you can move them freely on screen. They can be stretched. They can detect collisions with different parts of the screen, and so on. And basically, they're used to create moving graphics. So those are sprites, and the rest of it are characters. And they are usually used in games like that. But they can be switched to multicolor, and then they have like a smaller horizontal resolution. That's the common thing on Commodore 64. But they get additional common colors. And you can overlay one sprite over the other and get some additional details and better color. So this is actually image consisting of 3 sprites. Usually you use 2, but yeah, this one is 3. And you can quickly change the pointer to the memory which defines graphics, so you can have an animations like that. Commodore is famous for its sound, because at the time when it was produced, it had really, really great sound processor, which is used in many, multiple different pieces of hardware that generate music. It has 3 voices, 4 wave shapes, envelope control filters, and a bug in volume setting that was caused popping when you change the volume in a certain way, that you could use for a 4th sound or speech synthesis.
Another visitor. Stay a while. Stay forever.
So programming Commodore 64 is interesting because it consists of multiple different tricks that you need to use if you want to create modern demos or interesting games. For example, Sprite Multiplexing. Commodore can display only 8 sprites on screen. That's not actually true. It can display 8 sprites on a horizontal line of the screen. So if you display 8 of them and then get a raster interrupt that tells you that you already displayed them, then you move them below, change the pointers to the graphics, and you display 8 new ones. So this is pretty common technique. There is also a border around the screen, because it was displayed on the TV sets, and there was no such thing as a standard that what is the resolution of the TV. So they decided to put a border around the screen so you don't lose any pixels. And it was supposed to be impossible to disable, so you shouldn't be able to draw on it, but people figure it out. There is a faster scrolling, some raster bars, and many more different techniques that you can use. So this is a game called Creatures. And this is kind of amazing because it's like, first of all, it doesn't have border here. So it uses exactly this technique to opening borders. And it displays, you can only display sprites here. So those are like 8 sprites displaying the letters. Then you have like some sprites here, but then you have a boss, which is like a huge sprite which shouldn't be possible to achieve on the Commodore 64. But it actually consists of like multiple different sprites overlaid on top of each other and multiplexed, so it can be displayed like that. So you can take that to the extreme. So this one actually can, I think it's like 110 sprites on the screen, which is like, I think it's world record current. So it's an effect of not even a modern demo, but yeah, it's possible to achieve extreme numbers of sprites this way. And when you think of modern demos, then I don't even know where to start. One thing you need to be aware is that Commodore 64, the processor in the Commodore 64 cannot even multiply. You get things like that. So 3D objects. why don't we have 3D objects that cast shadows? Megahertz processor, 64 kilobytes of memory, and no multiplication. So this is a demo that was released this year, and yeah, it's... I don't even... Yeah. We are definitely privileged to live in a remarkable time, we developers, because programming Commodore 64 is easier than ever before. We can use emulators, we can use compilers on our computers, which are 1,000 times better than what we had before. And I want to challenge you to create a game or a demo for Commodore 64 this year. And I can help you. Yeah, I told you before I do screencasts. So there is a discount if you want to join them. But that's not all. Like, if you want to create a game, I'm doing workshops, and the one that I made last time was during the conference in Poznań. The next one will be in Krakow. And I have a show notes that you can follow and create the game in a couple of steps. So here they are. First, we change the background to black. Then we display the board. Then we display sprites. Then we move them to proper places. Then we change colors. Then we define the graphics. Then we move them slower, move them horizontally, move them using joystick. Then we detect collisions with characters and the sprites. And then we react on those collisions, so we can change levels when you have collision with exit. Then we color the graphics, and then we animate the graphics. And you can actually create a game like that in a day. So, oh, sorry. So if you go to 64bytes.com/socoded, then you will find a link to the show notes, to the workshop notes, where you can follow the tutorial to create a game like that. And you'll find the details on how to get the discount if you want. And yeah, basically, if you want to create a game, you can. And I guarantee that it's something that will... I'm not sure if it will make you a better developer, but it will definitely expand your field of view. And it is really fun. Make a game this year for Commodore 64. It's about time.